In this lesson, we are going to consider continuity of a function. The whole concept is about the dynamics of a function as it moves in the Cartesian plane. If there is a function like this, a function moving, we want to see whether the function will still continue to flow at a particular point, say A. This is f of x, x, y, and this is f of x. So is the function going to flow like that within the interval or range given? So maybe from 0 to A, is the function continuous, or beyond A, what is happening? So at A, what is happening to the function? In some functions, it will move. At A, the function may not exist and there will be hollow and there will be discontinuity at that point. It means the function does not exist at that particular point, so it will not flow. So the continuity we are talking about is about flow of functions, whether it will be uniform within the interval or at a particular point in the interval, the function may not have a value there. In that case, the function will not flow, it will be hollow. In some cases, functions may move. One will move this way, jump, then begin from another point here, also move that way. It means it doesn't exist. At that particular point, there is no solution. The function will not flow. So we want to test for continuity, and before that, we check for the definition of continuity. So definition. We want to find a definition of continuity. A function f is continuous at a number, say A, if and only if limit as s approaches A of function is equal to f of A. The limit as s approaches A of the function should be equal to f of A. This definition requires three things. If and only if f is continuous at A. If f is continuous at A, there are three things that requires that the function is continuous so that this statement will hold. One, we must find out whether f of A is defined. So we want to say that f of A should be defined. Should be defined. And if f of A is defined, that is, A is in the domain. That when you put A into the function must be defined. Again, limit as s approaches A of f of x must also exist. So the limit of this function should what? Exist. And if the function exists as s approaches A and the functional value is also defined, the last condition is that f of A should be equal to lim as s approaches A of f of x. What it means is that functional value may exist. The limit value as s approaches that particular point, A, may also be defined or exist. But the answers will not be the same. So before you can conclude that the function is continued at that particular point, functional value must hold, exist, or defined, limit must also exist, but the values must be the same. So assuming functional value is 3 and the limit is 6, they all exist, but 3 and 6 are not the same, so you can say that the function is not continuous. So we are going to get examples to show this continuity. So example 1. We have to show whether the following functions are continuous. And we have f of x equal to, if you have such a function, you want to find whether it is continuous at a particular point. So 3x squared plus 2x minus 3. 2x minus 3. This is a function, a quadratic function, and you want to know whether it will be uniform as it flows in the Cartesian plane at a particular point, say at x equal to 1. So we want to test the continuity of this function at x equal to 1. That is the first example. Good. So per the 3 conditions of continuity, per the definition we gave, we have to find f of 1. So 1, f of 1. So the functional value at 1 will be twice 1 minus 3. And when we simplify this, we are going to get 3 plus 2 minus 3. And the answer is 2. It means the functional value exists and the answer is 2. Then we also find limits as s approaches 1 of the function 3x squared plus 2x minus 1. And per our ideas in limit, this is a polynomial function, so we pick the limit term by term. And as s approaches 1, the first term will approach 3, second term will also approach 2, and the last term is constant. Sorry, the function was quoted wrongly. This place is supposed to be 3, and this value also changes to 3. So in that case, as s approaches 1, the function to the limit is also getting to the same 2. So per the definition, the limit must exist, functional value must also be defined. And per our solution, it is defined at the limit value, functional value at 1, then the limit also exists at 2. So, and the answer is 2. So let's try to compare. Since limit as s approaches 1 of f of s equal to f of 1, then, and the answer is 2. Then we say that then the function f of x is continuous. Is continuous at where? X equal to 1. Good. Let's take another example. The second example, we are also to show whether this function is also continuous. And we have h of x equal to the function is a rational function. X squared minus 9 divided by x minus 3. We want to find out whether the function will also be continuous at a particular point at x equal to 3. So in the Cartesian plane, when x is 3, will this function exist? Or will it be defined? So let's take the limit. Limit as s approaches 3 of x squared minus 9 divided by x minus 3. As s approaches 3, per the limit theorem, we have 0 over 0, and it's undefined. So we have to simplify. And the theorem says we simplify L as s approaches 3. What are the linear factors of the numerator? It is x squared x minus 3 x plus 3. And the denominator will also be x minus 3. So when we cancel the common factor out, we have limit as s approaches 3 of x plus 3. And as s approaches 3, we have 3 plus 3, and the answer is 6. So the limit exists. It is not enough for you to conclude that the limit exists and the function will also be continuous at x equal to 3. Per the definition, you have to test for 3 things. So find the functional value. We want to find h of 3. That is, when you put 3 into the function, it will be 3 square minus 9 divided by 3 minus 3. And the value here is 0 divided. So once it is indeterminate, it means the functional value or the function at 3 doesn't work. Once it doesn't hold, it means there's no time for you to even go and equate the two and see whether they will be the same. This one doesn't work. Therefore, we say that h of x is not continuous at 3, at s equal to 3. Since h of 3 is indeterminate, thank you.